Hi everybody, welcome to the digital classes of Narayana Group. I am K.S. sir. Today I am going to discuss January 24th shift 1 mathematics paper, of course which is a memory based question paper. So actual questions may differ, so please try to understand this point. Now let us go to the first question. So this is from the definite integrals, and we have a very simple problem based on the property of the definite integral, that is indefinite integral of you already know the f of x with respect to x, okay, for any function which is integrable. But now we are having integral of f of x with respect to x from a to b, and that is one of the standard formulae, which is nothing but integral of f of a plus b minus x with respect to x from a to b. Only thing is this time the given limits are what, 0 to pi by 2. So straight away if you apply this property for this one, the same function will now become the I is equal to, the sin x will change into the cos x here, because a plus b minus x is pi by 2 plus 0 minus x, which is pi by 2 minus x. So the numerator becomes cos x whole power 2023. Next the denominator, of course the denominator remains same, because sin x changes to the cos, cos changes to the sin there. So finally this is cos x whole power 2023 plus this is sin x whole power 2023, this is with respect to x from 0 to pi by 2. So if you add the previous, the given one, and of course this one, it is going to be 2i is equal to integral of just 1 with respect to x from 0 to pi by 2. So very clearly this is nothing but the integral of 1 is x only. So finally I is equal to pi by 4, which is very clearly the first one. So that is the answer for this one. Now let us go to the second question. So according to this one, we are supposed to find out the integral of the modulus of x square minus 3x plus 2 from 0 to 3. So recall the modulus x property. The modulus x is equal to x whenever x greater than or equal to 0. It is equal to minus x whenever x is less than 0. So just based on this property, the modulus x equal to x whenever x greater than or equal to 0, modulus x equal to the minus x whenever x is less than 0. So we are just going to use that one in the simplification of this. Depending on that one, we will split the interval, of course. So for what values of x, x square minus 3x plus 2 is positive. For what values it is negative. To find out this one, let us take x square minus 3x plus 2 greater than or equal to 0. So the factors are x minus 1 into x minus 2, and that is greater than or equal to 0. So in this case, the x belongs to, that is the minus infinity to, that is 1. So one side it is closed, of course, and union 2 to infinity. So whenever x lies between, that is what, 2 to infinity or 1 or less, obviously this is positive. Quite obviously x square minus 3x plus 2, and that is less than 0. If you take this one, x minus 1 into x minus 2, and here we have the less than 0. So x belongs to 1 to 2, the open interval. So in this interval, the x minus 1 into the x minus 2 is very clearly, that is negative. So we have to split the interval. The given domain of the function is what, 0 to 3, means what, 0 to 1 if you consider very clearly, there the x square minus 3x plus 2 is positive. Similarly beyond 2 also it is positive. So we will split the interval like what, the same I is now going to be written as, this is 0 to 1, but in between 0 and 1 it is very clear, that is positive, x square minus 3x plus 2 is positive. So here modulus of this one will be taken as x square minus 3x plus 2 with respect to x, but whereas in between 1 and 2 it is negative. So modulus of x will be equal to the minus x here. So following the same logic, this is minus of, here we have the x square minus 3x plus 2 with respect to x between the limits 1 and 2. But whereas from 2 to infinity it is actually positive. Of course in the given domain we have up to 3 only. So this is plus integral of 2 to, this is 3, and there it is anyway positive. So x square minus 3x plus 2 with respect to x. So this is what we are supposed to simplify, of course, and we are dealing with just 3 terms only in every case. X square integral x cube by 3, 3x integral is 3x square by 2, 2 integral is 2x, and then value at the upper limit minus value at the lower limit. When you simplify this one, finally this value is going to be 22. Of course that is a simple calculation, and now we will go for the next question. So in this case, a tangent at a point P on the ellipse. In this ellipse very clearly a greater than b. Of course the equation of the tangent is x by a cos theta plus y by b sin theta equal to 1. So you keep it as a cos theta comma b sin theta only. In the final step, of course, you can simplify that one by just writing a value as 6 there, b value as 4 there. So what is any point on this one? Any point on this one is a cos theta comma b sin theta, that is 6 cos theta comma 4 sin theta. So at this point we are supposed to take the tangent equation. So what is the tangent equation? That is x by a cos theta plus y by b sin theta equal to 1. So let us take x by a, that is 6 cos theta, plus y by b, that is y by 4 sin theta, and that is equal to 1. So this is the equation of the tangent, but it is intersecting the coordinate axis in a and b. Of course, a coordinates you are going to get by simply writing y0 in this one. So this is going to be 6 by cos theta comma 0. These are the coordinates of a. Similarly, the b coordinates are, put x0 there. So you will obviously get 0 comma 4 by sin theta. But we need the minimum value of AB. Of course, AB is the portion of the tangent intercepted between the coordinate axis. So, and we will just find out the AB square. So that once we find out the minimum value of AB square, obviously the minimum value of AB can be taken up. So let's take the AB square, which is square of the distance between the points A and B. So what is the distance between A and B here? That is 6 secant theta minus 0 whole square. So that is 36 secant square theta. Next plus, and 0 minus 4 by sin theta whole square, that is 16, that is cosecant square theta. Okay, but here to find out the least value of this one method is obviously the derivative concept we can apply. But instead of that, what we are going to do is, we will just apply the am greater than or equal to gm concept for this one. Okay, let us check it out. So this is 36 secant square theta. So 36 into 1 plus tan square theta. This is what we can write. Next 16 cosecant square theta. So 16 into cosecant square theta 1 plus, this is cot square theta. Okay. So after that, the constant term can be separated, which is 36 plus 16. Of course, the next term 36 tan square theta. Here we have the 36 tan square theta plus 16 cot square theta. Only this part we are now going to take, 36 tan square theta plus 16 cot square theta. And in this case, instead of the calculus method, we are just going to use the simple concept am greater than or equal to gm, so that we can find out the least value of this expression. So what is the least value of 36 tan square theta? So just use the formula a plus b by 2 is greater than or equal to root over ab. So that is the am greater than or equal to gm concept. So we will apply that one for only this part. So something like a plus b there. So the 36 tan square theta plus this is 16 cot square theta whole divided by 2 is greater than or equal to the product of these two. That is nothing but 36 into 16 into cot square theta into tan square theta. So that's obviously that is 24. Okay, because tan square theta into cot square theta is the one here for all permissible values of theta, of course. Okay, so when you simplify this one, the least value of this expression is nothing but what? 48. So finally, AB square is now very clear, that's greater than or equal to this 36 plus 16, that is 52, plus the least value of the second part, which is 48. So what is the least value of AB square means 100, and the least value of AB obviously is nothing but what? So in this case, very clearly we are now going to have the same value, which is AB. Of course, AB value is greater than or equal to 10 only. So that is the least value of the length AB. Of course, we did find out the least value of AB square. Now from that one we can say that the least value of AB is nothing but 10. So 10 is the answer for this one. Now let's go for the next question. So in this case, sigma r square into 2023 CR is the given one. Of course, we are supposed to recall the formula, that is NCR. What is NCR actually? NCR from the permutations and combinations, we know that n by r into n minus 1 C r minus 1. Again and again you can apply this one any number of times, of course. What I mean is n by r into, again n minus 1 by r minus 1 into n minus 2 C r minus 2. If necessary, we can apply that one. So let us take this r square into that 2023, that is a CR. Otherwise you take it as NCR, of course, no problem. So in this case, 2023 CR, this is the given one, r square into 2023 CR. But I am now going to write this one as r square, next this is minus r, okay, next to plus r, means we are adding and subtracting r there, into 2023 CR. So that r is common here, so this is nothing but r into r minus 1. So the first part of this one is r into r minus 1 into 2023 CR, next plus r into 2023 CR. But what about the NCR formula? Just now I told you the NCR formula is nothing but n by r into n minus 1 CR minus 1. So if you apply that formula once, then r will get cancelled. Again if you apply that formula, even r minus 1 will get cancelled. So applying this formula twice here, you are just going to get the 2023 by r into 2022 CR minus 1. So finally this is 2023 into 2022 into, that is 2021 C r minus 2, because r and r minus 1 are getting cancelled when you apply this formula twice, of course. What the next one? Same formula if you apply for the second part, r will get cancelled, 2023 into 2022 C r minus 1. Now you apply the sigma for this one. Anyway, this is a constant that can be taken out. Okay, so the first part is 2023 into 2022 into sigma. So this is the value you are going to have, 2023 into 2022. Next that is the sigma. Here we have the 2021 C r minus 2. Originally r is given as changing from 0 to 2023, but now we can't take that one because the subscript is r minus 2. That cannot be negative, as we know. That's why r is changing from 2 to 2023. This is what you are supposed to take. That's the first part. What about the second part? This 2023 is common, and then this is sigma, that is the 2022 C r minus 1. R is changing from 1 to 2023. You should not take again 0 from, because quite obvious the r minus 1 should not be negative. It can be 0 and maximum it can take up to 2022. That's why r minus 1 means here r is changing from 1 to 2023 you are supposed to write. Now straight away use this formula. What is that one? When you go on substituting the values like r equal to 1, 2, 3 and so on. So quite obviously you are going to get this formula, C0 plus C1 plus C2 and so on up to Cn, which is nothing but 2 power, that is n. This is the formula we are supposed to apply, C0 plus C1 plus C2. This is one of the standard formula, as you know. So when you apply this one, finally taking the 2023 common and simplifying this one, this is the value you are going to have, that is 1012. So that is the value you are going to have there. Please go through this one. Okay, a simple formula, one is NCR equal to n by r into n minus 1 CR minus 1. That can be applied any number of times. One more formula which we have applied is C0 plus C1 plus C2 and so on up to Cn, which is nothing but 2 power n. So let's go for the next question. So in this case, let us go through this one. There are 12 subjects in a class, out of which 5 are language subjects. A student has to choose 5 subjects in which at most 2 are language subjects. Find the number of ways in which we can do this. So maximum 12 subjects are there, 12 subjects are there, out of which 5 are language subjects. Even though it is not mentioned that they are different, obviously it has to be taken for granted. They are obviously the different subjects only. Language subjects, but no doubt they are different language subjects. That is what you are supposed to assume. So if that is the case, 7 other subjects, here we have the 7 other subjects, 7 other. And what about the language subjects here? There are 5 language subjects. Okay, but maximum you have to select what? 2 language subjects only, but a total of 5 subjects have to be selected from these 12 subjects. So the possibilities one by one we are going to write. So here you can select 5, there nothing. That is one of the possibilities. Otherwise 4 here, 1 there, or 3 here, 2 there. So obviously these are the possibilities. 5 other subjects and 0 language subjects. So in this manner, if you can do this, obviously you will get the total possible ways in which we can do this one. So 5 from 7 can be done in 7C 5 ways. Okay. Next one, and out of the 5 language subjects, 0, that is 5C naught. This is the first case. Or obviously this is the first case, or the second one, or the third one. What about the next one? That is nothing but 7C4 into, that is 5C1. Okay. and the third one, this is 7c3 into, that is 5c2, that's it. So if you simplify this one, you will be getting the value, of course that is this one. Whatever it is, basically this is the method to be followed, fundamental principle of multiplication. We can do this job in 7c 5 ways, and that can be done in 5c naught ways here. Together it can be done in 7c5 into 5c naught ways, or the second one, third one. There are total 3 possibilities here. We have taken up all of them. Okay, so that is the value for this. Now let's go for the next question. Now in this case, find the area bounded by the curves. Only a simple curve has been given, a standard curve. One is parabola, the other one is straight line. So area bounded by these two means probably they are intersecting. So let's find out the point of intersection, and let us trace the curve also. Is it opening to us west direction or east direction? How to decide all this? Take the parabola and convert this one into standard model. Y square equal to minus 4 into x minus 1. So it is having the vertex at 1, 0 and opening to us west direction, and it will intersect the y axis, of course symmetrical about x axis. So similarly, at what points the line and the curve are intersecting, this is what we are supposed to take up. So in this case, as far as the diagram is concerned, here the parabola is opening to us west direction. This is the origin, of course 1, 0 somewhere here. So the parabola is something like this one. Okay, and now as far as the line is concerned, it is having the positive slope, but at what point it is intersecting the y axis? And in fact, the curve and the straight line both are intersecting the y axis at the same point. You can clearly go through that one. Same point or not, you can just find out, of course. So what about this value? When you put x0 in this one, and this is going to be what? 0, 2. Okay, and this is 0, minus 2. Okay, because when you put x equal to 0 here, y equal to plus or minus 2. So those are the points 0, 2 and 0, minus 2. At what point this line is intersecting the y axis? When you put x0, y is equal to what? 2 only. Means the same point 0, 2. What about the next one? When you put that is the y0, x equal to minus 1. So it is going to intersect this one in this manner. So the required area is the area bounded by these two, and this is a possible diagram. Okay, but obviously area bounded by the two curves means you can calculate with respect to y or with respect to x. Obviously through the points of intersection, but at what point they are intersecting? One point is certainly 0, 2. Other point, if you want to find out, just eliminate y from those two or even x from those two. Anyway, we need horizontal lines. Why it is so means, if you take up this line and also this line, between the two horizontal lines, the entire area, whatever is the given one, the entire area bounded by these two is exactly lying between these two. So it is better to calculate with respect to y only, whereas through the points of intersection, if I take vertical lines, the entire area does not lie between them. So because of this reason, we are supposed to integrate this one with respect to y only. So what about this line? That is y equal to 2 line, that's very clear. This is y equal to 2 line, which is one of the lines passing through the points of intersection. Let's go for this one. So when you eliminate x term, so the y square equal to minus 4x, that is minus 2 into 2x, but 2x is the y minus 2 there, and next plus 4. So very clearly this is y square, next plus 2y, next here we have the, and that is minus 8 equal to 0. So this is nothing but y plus 4 into y minus 2 is equal to 0. So one of the values is y equal to minus 4, other one is 2. Already we got y equal to 2 line, so this is y equal to minus 4 line. So this is y equal to minus 4 line. So simply upper curve minus lower curve from minus 4 to 2 there, that's all. So what is area bounded by these two means? You express this one, x as a function of y. The reason it is the upper curve as far as the with respect to y is concerned, you should be taken as the upper curve, this is the lower curve. So separate the x value from this one, which is y square, otherwise 4 minus y square by the 4. This is 4 minus y square by the 4. And the next one minus, and you are supposed to take the x value from this one, which is y minus 2 by the 2. So the value you are supposed to integrate this one between the limits minus 4 and 2, that's all. So this is what you are supposed to apply with respect to y, of course, because I told you whenever the area bounded by the two curves is required, you are always supposed to consider the points of intersection of the two curves, and after that take the two lines through their points of intersection. If the entire area is lying between them, you take the horizontal lines only from lower limit to the upper limit, or if you take the vertical lines, if the entire area is lying between them, you are supposed to integrate that one with respect to x. Here, through the points of intersection, you can't take the vertical lines so that the entire area is lying between them. That's all. So when you simplify this one, you are going to get the value that is the 9 here. That's all. So as far as this one is concerned, I mean simply upper curve minus lower curve, but the limits are from -4 to 2 there. Okay. Now let's go for the next question. Okay. So in this case, x square minus 4x plus 3, it can be factorized of course, and equal to x into step x minus step x. And now what is the number of solutions in the given intervals? In the respective intervals, how many solutions are there? So let us consider the given equation, that is x square minus 4x plus 3 is equal to, here we have the x into step x minus step x. So you can take step x common. So this is x minus 1 into the step x. As far as the LHS is concerned, we are having x minus 1 into x minus 3 of course. So you can't cancel x minus 1 unless you know that is not 0. I mean, so this is x minus 1 into that is step x. So in this case, you can bring all the terms to one side, x minus 1 can be taken common. So this is x minus 1 into, what about the remaining terms here? Here we have the x minus 3, next minus step x, and that is equal to 0. So that means either the first one is 0 or the second one is 0. If it is first one the 0, for example, x minus 1 equal to 0, x equal to 1, that certainly is one solution. Similarly, the next one, x minus 3 equal to, that is the step x, this is the second one. Either the first one is 0 or the second one is 0. First one is 0 means x equal to 1, certainly that is one of the solutions. And as far as the next one is concerned, x minus 3 equal to step x. Since we are dealing with the step x, that can be an integer, of course, depending on x is what, an integer or not. Step x is always an integer of course. But the thing is, there are two cases as far as this one are concerned. One is x is an integer, x is an integer. Next one, x is not an integer. Okay, x does not belong to either. So it can be something like 5.1 for example. Okay, whenever x is an integer, step x will be equal to what? X only. Then x minus 3 equal to x means, so in this case let us see whether there is any solution or not. So here we have the x minus 3 equal to step x, which is equal to x only. I mean of course we are just having, I mean the factors, what is that one? X minus 1 into x minus 3, here x minus 1 into step x. So are we going to have any solution for this one means? No. Okay, very clearly there is no solution here. But suppose that x is not an integer, then for example, whenever x is not an integer, okay, here also we will get what? X minus 3 equal to some integer only. So what I mean is, in this case, there won't be any solution even for the second case, even when x is not an integer. Here also no solution because, and the step x, whether x is an integer or not doesn't matter, step x is always an integer. I have taken the case one where x is an integer, there x is not an integer. Even if you take the graphs of y equal to x minus 3 separately and y equal to step x, okay, so these two graphs will never intersect, and you can take the graph of y equal to x minus 3 and y equal to step x there. Okay, y equal to step x means what? The step x graph, if you take the values here, okay, these two graphs will never intersect, and whereas in this case there is no solution, there also there is no solution. So finally this is the only solution we are having, and according to the options you can clearly see that the number of solutions in the set of real numbers is 1. So whereas in this case he is saying that minus infinity to 1, okay, there open interval is given, and in this case open interval. So here 1 is not there. So it's very clear this is the only possible answer, because whatever is the given equation we have factorized on the LHS, and after that common term x minus 1 has been taken. X minus 3 is equal to step x here. So whether x is an integer or not, here there is no solution, whereas in this case only one solution. Finally, number of solutions in this one is just 1 here. So to decide this, you can take the graphs of y equal to x minus 3 and y equal to step x also. They will never intersect, and for any, what is that one? The fractional values of x here. Okay. So now let's go for the next question. So in this case, it is a singular matrix it was given. Singular matrix means obviously what? The determinant of that one is 0. And next, alpha is the root of this equation. The interesting thing is, alpha is the root of this one, it's okay. But what is the sum of the coefficients here? It's very clearly 0. A minus b plus b minus c plus c minus a is 0. Whenever sum of the coefficients is 0, from the quadratic equations we know that 1 is the root of that one, very clear. Okay, now you take this one, the determinant of this one is 0, determinant of 1 alpha alpha square, next c a b, and this is 1 1 1, and this is equal to 0 because it's a singular matrix, it was already given. So when you expand this one, alpha square into, very clear, alpha square into c minus a, next minus alpha into, that is c minus b there, and next plus 1 into a minus b. So this is what we are having. Okay, of course this can also be taken as alpha square into c minus a, next plus alpha into, that is b minus c, next plus a minus b. So here also very clear, sum of the coefficients is 0. So obviously whenever sum of the coefficients is 0, it's very clear alpha equal to 1 is a possibility. Same thing happens here also. So that means what? Alpha equal to 1 is the possibility. So very clearly the given equation, since alpha is the root of this one, we got one more equation, a minus b into alpha square plus b minus c into alpha, next plus c minus a equal to 0. We have the two equations, very clear. This is one equation, this is the second one. And in the given equation, sum of the coefficients is 0. In the determinant of this one equal to 0, we have same model equation where sum of the coefficients is 0. Of course, the second equation is obtained from the first one by replacing alpha with 1 by alpha. You can clearly see that when you replace alpha with 1 by alpha, you are going to get this one. So, and very clearly 1 is the root for this one. So, here also 1 is the root for this one, very clear. So, you can clearly say that a minus b plus b minus c plus c minus a equal to 0. Okay, you take them as some x plus y plus z, for example. Okay. Whenever x plus y plus z is 0, there is a standard formula. We know that x cube plus y cube plus z cube is equal to 3xyz. So in the same manner, a minus b plus b minus c plus c minus a is 0. If that is the case, a minus b whole cube plus b minus c whole cube plus c minus a whole cube is equal to 3 times a minus b into b minus c into c minus a. Quite obvious, because whenever a plus b plus c is 0, a cube plus b cube plus c cube equal to 3abc. In the same manner, a minus b plus b minus c plus c minus a is 0. How did you come to this conclusion? Means alpha equal to 1 satisfies both the equations. So very clearly, alpha equal to 1 is the root for this one, that's very clear. So that's why a minus b whole cube plus b minus c whole cube plus c minus a whole cube is equal to this one. Same thing you are going to get here after taking the LCM. When you take the LCM for this one, you are now going to have a minus b whole cube plus b minus c whole cube plus c minus a whole cube whole divided by a minus b into b minus c into c minus a. According to the result we got, this value as what? 3, that's all. So 3 is the answer for this one, and that is obtained from this one, of course. Okay, so here the answer is the first one. Now let's go for the next question. So in this case, two straight lines are given. What is shortest distance between the two lines? This is one of the standard questions in the three-dimensional geometry. Very clear. You can use the formula for the shortest distance between the two lines here. Obviously, they have to be the skew lines. We need not worry about that. Of course, we can verify whether they are skew lines or not. So imagine the first line as r bar equal to a bar plus t times b bar. Second one, r bar equal to c bar plus s into d bar. If these are the two skew lines there, as we know, the shortest distance between the skew lines is r bar, is equal to a bar plus tb bar. Means what does it mean? It is passing through a point whose position vector is a bar parallel to the vector b bar. Similarly, this is the vector equation of a straight line passing through c bar, a point c bar, of course, parallel to d bar. What is the shortest distance between the skew lines here? So the shortest distance between the skew lines is, this is the shortest distance we are using the formula. The modulus of the box a bar minus c bar, b bar, d bar, and divided by modulus of b bar cross d bar. So this is the shortest distance between the skew lines. But how to convert this one into this model? Because from the vector algebra we already know this formula. So straight away this can be converted into this model. How means? Already you know that this line is passing through 2, 1, 0. So that is the position vector of that point here. So the first one is r bar equal to that is 2I bar plus j bar, next 0 into k bar. So this is only in place of a bar, plus t times the vector to which the line is parallel, 3I bar plus 3j bar. This is 3I bar plus 3j bar plus 2k bar. So straight away the first one has been converted into, the vector form. The 3D straight line has been converted into vector form. Similarly, the next one, r bar equal to, even that one is passing through one point there, 1 to 1. So this is I bar plus, that is 2j bar plus k bar, next plus s into, it is the vector to which the line is parallel, which is 3I bar plus 2j bar plus 3k bar. Straight away, first one is r bar equal to a bar plus tb bar, second one is r bar equal to c bar plus sd bar. The shortest distance between the two skew lines is this one. Straight away, if you apply this formula, you are going to get this value, which is 11 by root over 43. Straight away the simplification, everything is very clear. This is a bar, this is c bar, that is b bar, this is d bar. Straight away apply this formula. The box of course the modulus of box of a bar minus c bar, b bar, d bar by the modulus of the b bar cross d bar. The shortest distance between the skew lines. Okay, now let's go for the next question. So in this case, f of x equal to a piecewise function has been given, x square into sine 1 by x whenever x is not 0. Whenever x is 0, it is equal to 0. So value of the function has been given. Now let's find out whether f is continuous or not, because in majority cases it is given as f is continuous, discontinuous, something like that. Let's find out this one. For a function to be continuous, as we know, left hand limit, right hand limit, value of the function, all the three must be equal. So let's calculate the left hand limit. What is the left hand limit? Limit of f of x as x tends to 0 from the left side. So let us calculate this one. Limit of x square into sine 1 by x. Limit of this one as x tends to 0 from the left side, because value of the function is already given. Now when x tends to 0 from the left side, 1 by x will approach minus infinity. Sine of something approaching minus infinity is an oscillating value between minus 1 and 1. So some value oscillating between minus 1 and 1 into 0 will give you 0 as a value for this. So it's very clear. Second one is oscillating between minus 1 and 1. First one is tending towards 0. Together it will approach 0. That is the left hand limit. Similarly, limit of the x square into sine 1 by x as x tends to 0 from the right side. So in this case, very clearly here also the same logic. When x tends to 0 from the right side, 1 by x will approach plus infinity. Sine of something tending towards infinity means it is just an oscillating value between minus 1 and 1 into 0 will give you what? 0. So left hand limit 0, right hand limit 0, value of the function is 0. So the function is continuous. F is continuous given in how many options here? That is the first and second. And whereas in the third and fourth it was given as discontinuous. So these two are obviously wrong. Just one more thing we have to find out, that is what? F dash is discontinuous at x equal 0 or not. Here f and f dash both are continuous in the second one. Let's find out this one. Let's find out that is differentiability at x equal to 0. Okay, you can recall the definition, that is limit of f of x minus f of a by the x minus a as x tends to a. Limit of this one as x tends to a, if it exists as a finite value, then we will say that it is differentiable. Limit of this one exists as a finite value means whether x tends to a from the right or left, it doesn't matter. It should approach a finite value only, and both of them must be equal also. Then only we will say that it is differentiable. So straight away, here you can take what is that one? F of 0. So differentiability has to be verified at x equal to 0 only, very clear. So if you go for that one, this definition, limit of the f of x as x tends to 0 from the right or left, it doesn't matter, same function we are supposed to take. So x square into sine 1 by x, next minus f of 0, that was given as 0 there, very clear, whole divided by this is what? X minus 0. Limit of this one as x tends to 0. So very clearly when x will get cancelled, you are still left with limit of what is that one? X into the sine 1 by x as x tends to 0 from the what is that one? This is 0 from the right or left here. Now in this case, limit of this one. So here we are having x into sine 1 by x. Limit of this one should exist as a finite value. Okay. So in this case, here they did not give it as discontinuous, differentiable or not. So very clearly, If it is not differentiable, automatically we can say that, will you say that it is not continuous means there is no such guarantee. Not continuous means not differentiable. Not differentiable does not guarantee the, what is that one, and that is in this case very clear, x into sin 1 by x, we have the limit. So as x tends to 0 from the left or right, we can find out the limit of this one. Both of them should exist as a finite value. But f dash actually, okay, so very clearly is it differentiable means at x equal to 0, I mean if you verify the differentiability, limit exists for this one. Whereas separately if you find out f dash x here, what is the value for this one? Here we have the x square into sin 1 by x derivative, that is cos 1 by x into 1 by x derivative minus 1 by x square. Okay, next plus sin 1 by x into, and we have the, I mean that is, okay, so this is sin 1 by x into, that is x square derivative, which is 2x. Okay, so here f dash x. Now what is f dash 0? F dash 0 is not defined. So will you say that f dash x is continuous means, first of all value of the function is not defined at x equal to 0. We have taken f dash x here. Okay, so it is not defined at x equal to 0. Very clearly the function is that is not continuous. F dash x is not continuous at x equal to 0 because value of the function is not defined, very clear. So that's why here it's a very clear, it is nothing but what, the first one, discontinuous at x equal to 0. So even second option is wrong there. So the first option is correct. We have verified the continuity of the first one. What I mean is f of x and even f dash x here. Okay, so now let's go for the next question. So this is limit of 1 power 1 by sin square t, and here t tends to 0 is given. Whether t tends to 0 from the right or left here, sin square t will approach what, 0 only, from the right only. So 1 by sin square t will approach what, plus infinity. So here it's very clear whether t tends to 0 from the right or left, very clear. In both the cases t square, I mean what is the given one actually, sin square t of course. So in this case sin square t. So sin square t, I mean this value, if you take this one, it will approach 0 only from right side. So 1 by sin square t will approach what, that is plus infinity. This will approach plus infinity. Now in this case let us take n power 1 by sin square t common. So whole power sin square t we have. So we are now going to get n outside the bracket. What about the rest of the terms here? 1 by n whole power 1 by sin square t. Similarly second one, 2 by n whole power 1 by sin square t. Okay, so this is sin square t, and so on. The last one, just one only, whole power sin square t we have. Now except the last term, if you observe the remaining terms here, they are all something like what, 1 by n, 2 by n and all that. So they are all between 0 and 1, whereas the power is tending towards infinity. When you take a value in between 0 and 1 there, as the power tends to infinity, the value tends to what, 0. So that's why all these terms will become 0 except the last one. All the terms except the last term will become 0. So n into 1 power means what, base is tending towards 1, power is tending towards 0. So 1 power 0, not 1 power infinity, it's 1 power 0. So finally this is n into just 1, it's equal to n. So the second option is the correct answer. Now let's go for the next question. So in this case, find the minimum distance of the point. What is the point here? 7, minus 4, minus 3 from the plane formed by the 3 points. So here to find out the plane formed by the 3 points, you can either go for 3D concept or vector algebra concept. Anyway, you will get the plane equation. Once you get the plane equation, directly the minimum distance of the point means what? Shortest distance from a point to a plane. That is the perpendicular distance only. So just in this problem, finding the plane equation is important. It's a very simple problem, as you can see. So how to find out the plane equation? Passing through the 3 points. One method is you can find out the plane equation by this formula, standard formula, x minus x1, x2 minus x1, x3 minus x1 in the first column, y minus y1, y2 minus y1, y3 minus y1. Next z minus z1, z2 minus z1, z3 minus z1, and this is equal to 0. So this is the plane equation. Straight away you can apply this one. Otherwise you can also form the plane equation by this method. R bar minus a bar dot n bar is equal to 0. What is this a bar means? Position vector of one of the points on the plane. N bar is a vector normal to the plane. How to get a vector normal to the plane? Assuming that the three given points are A, B, C, AB bar cross AC bar you can form. So out of the 3 points, any one you take in place of A bar. So N bar is simply AB bar cross AC bar. You can alternately follow this method also. Just take AB bar cross AC bar, where ABC are the 3 given points there. Other than the first point, still 3 more points are there. Take them as AB bar cross AC bar. You will get a vector normal to the plane, and in place of A bar, position vector of any one of the 3 points you can take. You will get the plane equation. That is vector algebra concept. Otherwise, use this 3D concept. Finally, you will get the plane equation. Once you get the plane equation, say for example, the plane equation is AX plus BY plus CZ plus D equal to 0. Okay, and the point is x1 comma y1 comma z1. Then what is the distance of this point from the plane? It is modulus of the shortest distance, of course, modulus of AX1 plus BY1 plus CZ1 and plus D by the root over A square plus B square plus C square. So if you apply this one straight away, you are now going to get root over 19 by 2. Of course, the direct application of the formula. So one is the plane equation, either by 3D concept or vector algebra concept, and once you get the plane equation, find out the perpendicular distance from the point to the plane, and that's how we are supposed to solve this problem. Now let's go for the next question. So in this case, capital N is decided by rolling a normal die, and k by 6 is the probability that the system of equations has a unique solution. Then find the sum of all possible values of k and n. So if the system is having a unique solution, and from the concept we know that if they are having the non-homogeneous system, of course, if they have a unique solution, delta is not equal to 0. The determinant of the quotient matrix is not equal to 0. They are in the proper order only, x, y, z. So let us take the determinant of the quotient matrix, that is 1, 1, 1. Next one capital N, next 1 and 1. Next one 3, and this is capital N minus 3, and the next one is plus 1. So determinant of this one is equal to 0. Equal to 0 will give you actually the values of n, and those values actually it should not take. Otherwise, straight away write not equal to 0. The reason, we know that when the system has a unique solution, delta not equal to 0. Even if you write equal to 0, you will be getting the values of n which we are not supposed to take. Of course, you can directly take not equal to 0. Let us simplify this one by taking any row, any column, of course. So I am taking the third row to expand this. 3 into 1 minus 1, 0. Next minus of n minus 3 into, cancel this row and column. So it's 1 minus n. Okay, next this is plus 1 into 1 minus n. Okay, and that is not equal to 0. So in these two, 1 minus n is common. Okay, when you take 1 minus n common, in the bracket we have the 3 minus n, next plus 1. So finally n is not equal to 1, not equal to 4. Okay, these are the two values we got. N cannot take 1 and 4. So what are the values it can take? N is actually decided by throwing a die there. So actually 6 possibilities are there for n. 1, 2, 3, 4, 5, 6. But among them, n cannot take 1 and 4. The reason, he is saying that they have a unique solution. So what are the possible values of n? Possible values of n are 2, 3, next 5 and 6. Because 1 and 4 it cannot take. And next one, he is saying that n is decided by rolling a normal die, and k by 6 is the probability that the system of equations has a unique solution. Then what is the probability of having a unique solution? N can take these values, n cannot take 1 and 4. So that's why the probability is nothing but what? 4 favorable cases out of the total 6. But it was given as k by 6. That's why very clearly you can say that k is equal to 4 there. So what are the n values it can take? N is 2 or 3 or 5 or 6. Okay. So these are the values it can take, n can take. N actually can't take 1 and 4. So k can take 4 there, obviously. So now you can clearly see that sum of the values of n and k means 20 is the answer for this one. Because he is just asking the sum of all the possible values of k and n there. So that is the answer for this. Now let's go for the next question. Now in this case, 14th problem, numbers are formed by using the digits 1, 2, 3, 4, 1, 2, 3, 4 and 1. So repetition is there, of course. Okay. And how many digits should be there? The number of 9-digit numbers such that even digits occupy even places. So obviously here repetition is allowed there. even digits should occupy even places, but only thing is what? Same digits you are supposed to take, no new digit, and you can't take any digit more than the number of times it is actually appearing. So how many are there? 1 is occurring 3 times, so 1, 1, 1. Okay, next 2 is occurring 2 times here, 2 and 2, 3 is occurring and only 2 times here, 4 is also occurring, that is 2 times there. So here very clearly there are how many digits means 9 digits there. So you are supposed to arrange them in the form of a 9 digit number such that even digits occupy even places. So how many even digits are there? 4 even digits are there, 2, 2, 4, 4. So out of the 1 to 9, what are the even places means? Second place, fourth place, sixth place, eighth place. So exactly 4 places are there, and in those 4 places we have exactly 4 digits available which are even. So in the second place, fourth place, sixth place, and of course eighth place, this 2, 2, 4, 4 can be arranged in 4 factorial by 2 factorial into 2 factorial. Okay, this is the number of ways of arranging 2, 2, 4, 4 in the even places. Still 5 odd places are there, 1, 3, 5, 7, 9. In those places the remaining 3 ones and 2 3s should be arranged there. That is that can be done in 5 factorial by 3 factorial into 2 factorial. Of course this can be simplified. The first one can be done in 4 factorial by 2 factorial into 2 factorial ways. What is the first one? Arranging the even digits in the even places. Arranging the odd digits in the odd places, automatically you have to do that. So that is 5 factorial by 3 factorial into 2 factorial. So when you simplify this, finally you will get 60 as the answer. Of course this is the number of ways of arranging the even digits in the even places. Second one is the number of ways of arranging the odd digits in the odd places. That's all. Now let's go for the next question. So in this case, a circle with center at 2, 0 and largest possible radius is inscribed in the ellipse. If the circle passes through the point 1, alpha, then what is the value of 5 alpha square? So in this case, center of the circle was already given. It is an ellipse with a greater than b case here. So let us take the rough diagram for this one. Suppose that this is a ellipse, and now they have taken a circle with center at 2, 0. Obviously that is going to lie on the major axis of this one, and greatest possible, largest possible circle is required. So obviously in this case you can take the circle touching this one, something like this. Okay, it is touching this one, the greatest possible one, center at 2, 0. So this is the center 2, 0. So center of the circle is given, only thing is radius we don't know. This is a point of contact, say for example P. So we know that for a circle, if you take the normal at any point on the circumference of the circle, that will always pass through the center. So in this case, P is a common point for the circle and the ellipse. Okay, so let us take the normal at that point. What is the point P there? A cos theta, B sin theta. Normal at that point passes through 2, 0. That way you can go for that. Otherwise you can take the circle equation like this one, x minus 2 whole square plus y minus 0 whole square equal to r square. This is the circle with center at 2, 0 and radius r there. And we have the circle x square by 36 plus y square by 16 equal to 1. So this y square by 16 equal to 1. From these two eliminate y square, put delta equal to 0. You will get the radius of this circle. So after that, since 1, alpha is lying on that one, just eliminate the y square from these two, put delta equal to 0. This is one method. The reason they are touching each other, because largest possible circle he is saying. So you just find out the circle equation with radius r, since they are touching each other, because they have given that it is the largest possible circle. So they have to touch obviously. So basically the circle is inscribed in this one. So at the common point, okay, whether you take this point or this point doesn't matter, same x coordinate will be there, symmetrical one. So that's why delta has to be 0. This is certainly one method, thereby you will get a r value. Once you get the circle equation, since the point 1, alpha is lying on that, straight away you substitute that point in the circle equation. Okay, so alternate method, obviously you have to take the common normal. This is the normal at this point. So that is a tangent at that point. So what is the normal at the point P? So ax by cos theta minus by by sin theta. So ax means 6x by the cos theta. Next this is what? minus by by sin theta. So, minus b, what is the b value? 4 there, by sin theta equal to a square minus b square. So, 36 minus 16. So, this is passing through 2 comma 0, obvious. When you substitute this, you will be getting that is cos theta value, because it is very clear, it is 2 comma 0, the center of the circle. Normally at any point on the circumference of the circle always passes through the center of the circle. So, even if you apply this one, you will be getting cos theta. If you know the cos theta, straight away you will be knowing the p coordinates. Once you know the p coordinates, distance between center and point P is nothing but radius. So, you can follow any method, but finally you will get the circle equation. Straight away substitute 1 comma alpha in that one, because the circle is passing through that point. So, you will be getting alpha square value. Therefore, 5 alpha square, if you find out finally, you will be getting 59 as a value for this. Just go through that one. Once you follow this method or that method, does not matter. In either case, you will be getting the radius value. So, once you know the radius, you substitute the point 1 comma alpha in that one. That is all. Now, let us go for the next question. Okay. So, in this case, a simple problem in the complex numbers, and of course, a little bit of quadratic equations concept is involved. So, 1 minus root 3 into I whole power 200, it is equal to 2 power 199 and next into p plus iq, that was given. So, in this case very clearly, first of all, you have to convert this one into modulus amplitude form, 1 minus root 3 into I. So, this 1 minus root 3 into I whole power 200 means I will just multiply and divide with 2 there, because whenever it is a plus ib, we know that you have to multiply and divide with root over a square plus b square. So, that is nothing but root over 1 plus 3. So, that is 2, multiply and divide with 2 there. So, it is whole power 200. So, this is whole power 200. It is 2 into 1 by 2 minus root 3 by 2 into I whole power 200. So, when you simplify this one, 200 here. So, in this case very clearly we have the that is 2 power 200, and we got the power applies to both of them, and this is 1 by 2 minus root 3 by 2 into I, which is very clearly equal to, that is the minus omega, because we know that omega, one of the cube roots of unity, minus 1 plus I root 3 divided by 2. So, what is the minus omega? That is nothing but 1 minus I root 3 divided by 2. So, whatever is the value here, that is nothing but minus omega. So, this is minus omega whole power 200. Okay. So, we have simplified this one by writing in the modulus amplitude form. So, we got 2 power 200 into minus omega power 200. So, very clearly this is minus 2 omega whole power 200. So, in this case minus 2 power 200 is 2 power 200 only. Next omega power 200, omega cube is 1. So, obviously if you write this one as omega power 198 into omega square. So, very clearly this is finally only just omega square. So, in this case 2 power 200 into omega square, but that was given as equal to what? The 2 power 199 into p plus iq. So, what about p plus iq here? Omega square, when omega is minus 1 plus I root 3 by 2, what is the omega square? Minus 1 minus I root 3 by 2. So, this is 2 power 200 into the minus 1 minus I root 3 by the 2 there. So, and this was given as equal to what? 2 power 199. Yes, obviously 2 power 199 we have. This is 2 power 199 into minus 1 minus I root 3. So, this is the final one. But when you compare this one with RHS, 2 power 199 into p plus iq means what is the p value? P value is minus 1, q value is minus root 3, that is all. Once you know the values of p and q, straight away you substitute in the p plus q square, p minus q plus q square. You will be knowing the two roots of the required quadratic equation. So, in this case p value minus 1, q value minus root 3. So, this is minus root 3. Okay. So, minus root 3 and this is minus 1. Substitute both of them in the p and q places. Then you will be knowing the roots of the required equation. Then what about alpha, for example? Suppose alpha is p plus q square, where each value is known here, p and q values. Suppose that beta is, that is p minus q plus q square. This is the the beta value. Since you know the p and q values, obviously you can just find out the alpha and beta. Then the required one is what? what is the equation whose roots are these two? Means what? The quadratic equation whose roots are alpha and beta is given by x square minus x into alpha plus beta plus alpha into beta equal to 0. That's all. So when you simplify this one, you will be getting the third one as the answer for this. Okay, straight away find out p and q, find out alpha and beta, find the equation whose roots are alpha and beta. Now let's go for the next one. So in this case, tangent is drawn at a point on the parabola y square equal to 24x. It intersects the hyperbola xy equal to 2 at points a and b such that the locus of the midpoint of AB is a parabola whose directrix, latus rectum, these type of things were given. So let's find out first the tangent at a point on the parabola. What is any point on the parabola y square equal to 24x here? So this is, I mean, for a value that is very clearly the 24. So a value is equal to 6. So what is any point on this one? 80 square comma 280. So any point on this one can be taken as 80 square, that is what, 6t square comma 280, that is 12t. Okay, 80 square comma 280. So that is any point on this one. Tangent is drawn at this point. So what is the tangent equation? That is nothing but yt equal to x plus 80 square. So yt, the tangent at this point yt equal to x plus at square. A value is 6, 6t square. So this is yt equal to x plus 80 square. Okay, and this tangent is intersecting the hyperbola in 2 points a and b. Locus are the midpoint of AB. So for example, this is the hyperbola, of course, xy equal to 2 means this lies in the, this first quadrant and the third quadrant. Okay, whatever is this line here, this is intersecting this one in 2 points here. Probably these are the 2 points here, A and B. Okay, now the locus of the midpoint of this one is required. So take this midpoint as P. So this line, which is the tangent for the parabola, is intersecting the hyperbola in 2 points A and B. So take the midpoint of AB as P there. So since the locus of the P is required, so take the point P as x1 comma the y1. So once you take the point P as x1 comma y1, since it is a midpoint of a chord of this xy equal to 2, chord equation you are supposed to take. What is the chord equation? For xy equal to 2 at the point x1 comma y1, what is the chord equation? Chord having AB, chord having P as a midpoint. So what is the chord equation AB here? Of course, you are supposed to take that is what, 1 by 2 into the standard procedure for this xy1 next to plus x1y. Okay, next the minus 2 is equal to x1y1 minus 2. So the minus 2 will get cancelled. You are now going to have the xy1 plus x1y equal to 2x1y1. This is the chord AB. But the same line is actually the chord AB. So that means what? This equation and this one are both representing the same straight line. So ratio of the corresponding coefficients is same. Okay, so compare them. Like what? What is the x coefficient here? y1. Their x coefficient is 1. And here the y coefficient is x1. There the y coefficient is minus t, because you have to take all the terms to one side. Okay, next one. And what about the the constant term here, 2x1 y1. There the constant term is minus 6t square. So this is 2x1 y1 by the minus 6t square. So eliminate t from this one. You will be getting the locus of x1 y1, the locus of the point P, of course. So what about that one? So first of all, let's go for the t value. T value is minus x1 by the y1. Okay, t value is minus x1 by y1. Now if you take these two, so you can eliminate t from these two. So you can take the first and last also, of course, no problem. So y1 can be cancelled. So 1 equal to, it is x1 by the minus 3t square. So what is the t square value? T square value means x1 square by the y1 square, and that is the t square value equal to minus x1 by 3. So finally it is nothing but y square equal to minus 3x. This is the locus of the point P. So it's a parabola, no doubt. So once again, we got a parabola, of course the locus of the point P, which is nothing but a parabola whose latus rectum is that is 3, because in place of Fourier we have the 3 there, and the second one is the answer because of that reason. So simply we have taken first tangent equation at the point P, but the same tangent is a chord for the hyperbola. It is intersecting the hyperbola in A and B. Midpoint of AB has been taken as P there. So chord equation we got, and actually that is nothing but tangent equation for the parabola. Both are representing same line, ratio of the corresponding coefficients is same there. By eliminating t, we got a parabola as the locus of P. And he is just saying that locus of the midpoint of AB is a parabola whose latest sectum is what? 3. That is one of the options, of course that is correct. Now let us go for the next question. So in this case, y equal to y of x is a solution of the differential equation. So we have to convert this one into some standard form, variable separable, linear form, whatever it is. Let us convert this one into some standard form. So what is the given equation? X cube into dy, and next that is equal to 1 minus xy into dx. So you can now take the dx to this side. So x cube into dy by dx is equal to 1 minus xy. So if you divide with what is that one x cube there, you are now going to have the dy by dx equal to, this is dy by dx equal to 1 by x cube, next minus y by x square. Okay, so clearly we got a linear form, dy by dx plus y by x square equal to 1 by x cube. So linear in y, dy by dx plus py equal to q model. So you have to just find out the integrating factor. Okay, so what is the integrating factor? Integrating factor is equal to e power integral of p with respect to x. Okay, what is a p value? P value is 1 by x square. Okay, because here dy by dx plus py equal to q means p is 1 by x square, which is the function of x, and q is also function of x here. So this is e power, and here we have the, that is 1 by x square. So 1 by x square with respect to x, of course. That's nothing but the minus 1 by x. So e power minus 1 by x is the integrating factor. Once you know the integrating factor, what is the solution for this one? Y into integrating factor, y into e power minus 1 by x equal to, now we have to take the integral of q into integrating factor. In place of q we have the 1 by x cube. So this is 1 by x cube into e power minus 1 by x with respect to x. Okay, so this has to be integrated. You will get the constant of integration. To get the constant of integration, they have given y of 1 by 2. What is the meaning of this? When x is 1 by 2, y is 3 minus c. So once you integrate this one, taking what? Minus 1 by x as t. So if you take minus 1 by x as the t there, it becomes e power t. Minus 1 by x derivative is, that is 1 by x square. Okay, 1 by x square. Okay, then what is the value for this one? Dx, and this is dt. So y into e power 1 by x, and here we have the 1 by x into, 1 by x is minus t, because the 1 by x cube can be written as 1 by x into 1 by x square. So 1 by x square dx is dt, and e power minus 1 by x is e power t. This is dt. Straight away UV rule you should apply. So t is the first function, e power t is the second function. If you simplify this, you are going to get some plus c as a constant of integration. To find out that c value, at x equal to 1 by 2, put y equal to 3 minus c. Thereby you will get the constant of integration also. Once you get the constant of integration, obviously, now you should go for what is that one? Y of 1. So once you get this constant of integration, which is given by this data, of course, because y of 1 by 2 equal to this one means, what does it mean? When x is 1 by 2, y is 3 minus c. That's what. So basically, once you get a constant of integration, whatever it is, simply put x equal to 1 so that you can get the y value. Okay, so that's all. So when you simplify this one, you will be getting the 1 as the answer for this. Means what? When x is 1, what is the corresponding y value? Straight away, it is a linear form, it was simplified, and then after integrating this one, constant of integration can be obtained by this one. So once you get a constant of integration, put x equal to 1 so that you can get y value, that is only y of 1. So that's going to be 1 there. So now let's go for the next question. So in this case, A and B are the two square matrices of the same order, such that A square B equal to A square plus B. So this is given, A square B equal to A square plus B. Okay, this is the given one. Now using this, we should find out whether the first one or second one or third one or fourth one are correct here. So A square B equal to A square plus B means I can bring the A square to this side, so minus A square equal to B there. So now you can take this one. What is that one? A square is common. So when you take A square common, okay, see that when you take A square common, it is B minus I. It is equal to B there. So a square into b minus I equal to b we got. How did you get this one? Simply by taking a square common, of course. So b minus I. So what I am going to do is a square into b minus I is equal to b minus I plus I. This is what we are going to write. Add and subtract I there. So then bring the b minus I to this side. So a square into b minus I, next minus of b minus I is equal to I there. Okay. So this is what we got. So taking the a square minus I, and here this is b minus I here. So b minus I is actually common on this side. So very clear. Now you got this one. So I have taken a square b minus a square equal to b there. So it's very clear, a square minus I into b minus I equal to I there. In a similar manner, you can take even this one. That is what a square b is equal to a square plus b. This was taken. Now I am going to take previously we have taken a square to this side. This time I am now going to take this value. What I mean is that is a b common in these two. So that is a square b minus b is equal to a square. Previously we have taken a square to this side. So what is the common term here? B is common. So a square minus I into b is equal to a square. Okay, then this is, we are now going to write a square minus I into the b is equal to a square minus I plus I. Add and subtract I there. So very clearly when you bring it to this side, a square minus I, when you take common, and this is into b of course, minus of a square minus I, and that is equal to I there. So very clearly a square minus I, if I take common, and in this case we are now going to have the, what is that one? We have taken the b common on this side. So we are just adding and subtracting this one. So we are now going to have the a square minus I next into the, what is that one? The b minus I on this side. So this is equal to I there. When you equate these two here, you will finally get a square b equal to ab square. What I mean is this first one answer, a square b equal to b a square of course. So b a square, this is b a square. So this is what you are going to get here. So take a square to that side or b to that side. Simplify this one. You will finally get that is a square b equal to b a square as the final answer. Now let's go for the next question. So in this case, tan inverse 1 plus root 3 by 3 plus root 3. It is a very simple problem. Only thing is you have to simplify this one carefully. That's all. So here we have the tan inverse 1 plus root 3 by 3 plus root 3. So let us simplify this 1 plus root 3 by 3 plus root 3. So what is the common term? Root 3 common here. So when you take root 3 common in the denominator, this is 1 plus root 3. In the denominator, root 3 common. So this is root 3 plus 1. So finally it is equal to 1 plus root 3. That is a simplification of the first part. What is the tan inverse 1 by root 3? 30 degrees. Okay. Similarly, you take the root over 8 plus 4 root 3, the numerator of the, this term. So this can be simplified by writing, root over 8 plus 2 root 12, because this is 4 root 3. So this is something like alpha plus 2 root beta model. So find the factors of 12 in such a way that product is 12, sum is 8 only. So you are supposed to take 6 and 2 there. So this is nothing but root 6 plus root 2. Okay, that is the value for that one. In the same manner, simplify this denominator, root over 6 plus 3 root 3. So how to simplify this one? You just multiply and divide with 2 there. So 12 plus, this is 6 root 3 divided by 2 there. We are converting that one into alpha plus 2 root beta model. So what about this value? This is root over, and here 12 plus, this is 2 root 27. So this is what we can write, whole divided by root 2 of course. Okay. So factors of 27, 9 and 3, so that the product is 27, sum is 12 there. Then it is nothing but root 9 plus root 3 by the root 2. Okay. So here, this is 3 plus root 3. Here we have the 3 plus root 3 by the root 2. That numerator is root 6 plus root 2. See that? This is root 6 plus root 2, the numerator. And the denominator is, we have the 3 plus root 3 and divided by, this is root 2. When you simplify this one, you are going to get secant inverse 2 by, please check this one. This is root 2 into root 2, 2 there plus root 12 and divided by 3 plus root 3. So very clearly there we can see that it's 2 root 3, so 2 into root 3 plus 1. So here also root 3 into root 3 plus 1. So very clearly this is 2 by root 3. So what is secant inverse 2 by root 3? 30 degrees. So 30 plus 30 is 60, that is the answer for this one. That's all. It's a very simple problem from the inverse trigonometric functions. Now let's go for the next question. Consider a GP with fourth term 500. Sn denotes the sum of the first 10 terms of the GP such that S6 is greater than S5 plus 1. And what about this one? S7 is less than S6 plus 1. If the common ratio of the GP is 1 by m, where small m is a natural number, then find the number of possible values of m. Okay, that is the question now. First of all, let us take the first term of the GP as A, common ratio as R there. Since a GP with fourth term is given as 500, and that is what A into R cube, because the nth term formula A into R power n minus 1. It is the fourth term. This is the fourth term, which is A into R power n minus 1. This is given as 500. Okay, next. The sum of the first 10 terms of the GP is given as Sn. But what is the first equation they have given? S6 is greater than S5 plus 1. So that means S6 minus S5 is greater than 1. But what is the sum of the first 6 terms minus sum of the first 5 terms? That is nothing but what? 6th term. So indirectly saying that this is the 6th term greater than 1. But 6th term is A into R power, that is R power n minus 1 5, that's greater than 1. But we already know that A into R cube is 500. So A into R cube is 500 means this is 500 into, that is R square, that's greater than 1. So R square is greater than 1 by 500. Okay. So R is greater than, that is 1 by root over 500. So but R is equal to 1 by m, it was given. So because common ratio of the GP is 1 by m. Initially we did assume that is R there. So 1 by m is greater than 1 by root over 500. So m is less than, so here the first conclusion is m is less than root over 500. Okay, next one. Similarly, one more equation has been given. S7 is less than, this is S7 less than S6 plus 1. So very clearly S7 minus S6 less than 1 here. Okay, this is less than 1. So very clearly, and here S7 minus S6 means sum of the first 7 terms minus sum of the first 6 terms. That is nothing but 7th term, and that's less than 1. So A into R power n minus 1, so A into R power 6 less than 1. But A into R cube is 500. So 500 into R cube is less than 1. R is less than 1 by cube root of 500. Okay, but R is 1 by m. So 1 by m less than 1 by cube root of 500. Okay. So very clearly m is greater than cube root of 500. Okay. So we already know that m is less than root over 500, and according to this one m is greater than cube root of 500. Finally, cube root of 500 is less than m, less than root over 500. Now what is the requirement? That is what? Find the number of possible values of m. So m is already given as a natural number. So in between cube root of 500 and cube root of square root of 500, how many natural numbers are there? This is surely 7 point something. Okay. So the next natural number is 8. So 8 is less than or equal to m less than or equal to. So square root of 500 is roughly around 22 point something. Okay. That's why you should take up to 22, the nearest natural number in this interval. So very clearly, how many values are there means there are 15 values of m. So 15 is the answer for this one. Okay. Now let's go for the next question. So in this case, PQR lies on the sides AB, BC and CA respectively of triangle ABC, dividing them in the ratio 1:2. Then the ratio of the areas of the triangle ABC and triangle PQR. This is based on the simple triangle properties of triangle concept actually. So this is the triangle ABC. Okay. So in the triangle ABC, they have given that there are 3 points on the sides, that is what? AB, BC and CA. On AB, there is a point dividing the ratio 1:2. So maybe somewhere here, suppose that this is the point P, it is dividing the ratio 1:2. Okay. Similarly, there is a point here, somewhere here on the BC of course, and I am taking that point as Q there, which is dividing the ratio 1:2 only. And even CA, that's being divided in the ratio 1:2. So opposite to A, the side length will be generally taken as small a. That's why since it is 1:2, this length, okay, I mean this BQ part, similarly this QC part. So if you take this as A, you should take it as what? 2A obviously, so that the ratio is what? 1:2. Similarly opposite to B, if you take this as B there, that will be taken as 2B, so that the ratio is 1:2. So opposite to C, if you take this as C there, this will be taken as 2C. That's all. Otherwise use some other notation, no problem. Now area of the triangle PQR means you can take this one, of course. Okay. So they are asking ratio of the areas of the triangle ABC and the triangle PQR. So in this case the logic is simple properties of triangle, one of the formulae, area of the triangle ABC, for example, half AB sin C means what? 1/2 into product of the two side lengths into sine of the angle between them. Okay. So you can take area of this triangle ABC as area of the triangle PQR plus sum of these three areas. Okay. And that's going to give you the area of the triangle ABC. Let us suppose that area of the triangle ABC is delta, but that is also equal to, this is the area of the triangle ABC and that is delta. In that case it is equal to area of the triangle PQR, okay, and next plus sum of these three areas. So if you simplify that one, you are going to get triangle PQR area in terms of the, of course, the triangle ABC area. Let us take this one. So delta is equal to, that is what? Area of this triangle. What is the area of this triangle? Half into this length A, and that length is 2C. Okay. So here we are supposed to take, what is that one? Half into A into 2C into sine of the angle between these two. So this is half into, that is A into 2C into, that is the sine of the angle between these two, that is sine B. Of course I have taken this as A and 2A. So the side length should be actually taken as 3A here. Otherwise use some other notation, no problem. Similarly plus, what about that triangle area? Half into, that is 2A into, that is B into sine of the angle between them, sine C, plus 1/2 into the area of this one, that is C into 2B into sine of the angle between them, that is sine A. Okay, plus triangle PQR area, whatever it is. So in this case the area of the triangle PQR in terms of these terms we got, but actually area of the triangle ABC can also be obtained by this method. Area of the triangle ABC you can also take half into these two lengths. What is that one? 3A into, this is 3A into 3C into sine of the angle between them, because I have taken A and 2A, of course. Similarly same thing can also be taken as what? Half into this length and that length, that is nothing but 3A into 3B into sine of the angle between them. Next one, the same area is also equal to half into this length and that length, that is nothing but 3C into 3B into sine of the angle between those two sides, sine A. So whatever is AC you can substitute here. Similarly AB value you have to substitute here. Similarly BC value you have to substitute here. Then PQR area will be in terms of the delta. So then when you find out this ratio, it will be 3. That's all. See that here AC sin B from this one can be taken as 2 delta by 9. That value you substitute here. Similarly other two. Then PQR area in terms of delta we are going to get, and ABC area we have taken it as delta. That's all. Okay. Now let's go for the next question. So in this case, if capital R is a relation on the set of natural numbers such that A is in relation R with B if and only if greatest common divisor of A and B is 1. Of course 2A is not equal to B given. Then what is that relation? Is it reflexive, symmetric, transitive? We are supposed to verify. First of all, I mean if you take reflexive property. So according to that one, if I take A and A, so ordered pair of A and A belongs to that relation only when the greatest common divisor of these two is what? 1 only. But actually what is the greatest common divisor of A and A? GCD of this one, we are verifying the reflexive property. So this is equal to A, but that need not be equal to 1. It can be equal to some other value. For example 5 and 5 I have taken, both are natural numbers, but what is the greatest common divisor? 5. So but that is not 1. So according to this, now it is not reflexive because it need not be 1. So this need not be 1. It can be any other natural number also. That is why you can say that it is not reflexive. So is it symmetric or not? Let us check it out. Symmetric means what is the GCD of A and B, for example. Suppose that it is 1. Automatically this implies GCD of B and A also 1 only, obviously. So when that is true, this is automatically true. That's why it is symmetric. Okay, but to verify the transitive property, let us take an example. That is what? Ordered pair of 7 and 3. What is the greatest common divisor of these two here? Very clearly 1. I will now take the greatest common divisor of 3 and 49 for example. 3 and 49. That is, what about this value here? That is also 1. But what is the greatest common divisor of the 7 and 49? That is not 1. That is not 1. You can clearly see that the greatest common divisor of 7 and 49 is not 1. So what does it mean? So here, even though that belongs to that is the R, even this one belongs to R, the ordered pair of 7 and 49 does not belong to this, because greatest common divisor is not 1 here. So it is not true for every pair of natural numbers. That's why you can say that it is not reflexive but symmetric, and it is not transitive also. You can see this example. So that's why the answer is symmetric but not transitive. Now let's go for the next question, and that is, here consider vectors u bar and v bar are given. In vector algebra, this is of course one simple problem. They have given u bar and v bar. Consider a vector w bar such that v bar cross w bar equal to u bar plus lambda times v bar. Moreover, v bar dot w bar has been given. Then what is the, the value? Which value? Of course, here the value of u bar dot w bar is required. First of all, you think about this one. To find out the lambda value, we need some condition. But anyway, we know the u bar and v bar. So what I am going to do is, since v bar cross w bar is given, which is u bar plus lambda times v bar, okay, this is given of course. I will now take LHS cross product with v bar. See that this is v bar cross w bar. Okay, this is w bar, and that is equal to v bar cross, here we have the u bar plus lambda times v bar. So what happens here? V bar cross lambda times v bar is 0 bar. Okay, so you are now just left with what? Vector triple product. So v bar dot w bar into the v bar, next minus v bar dot v bar into w bar is equal to just v bar cross u bar. Second one is null vector, of course, whatever is the lambda value. Okay, that's all. Now here everything is known. U bar dot v bar you can find out, and v bar dot w bar has been already given. What is that one? 2 there. So 2 times this one. What is v bar dot v bar? So this is nothing but 2 times v bar. Next minus v bar dot v bar is very clearly, it is nothing but the modulus v bar whole square, which is nothing but 3 times w bar. It is equal to v bar cross u bar. So v bar cross u bar also you can find out. So 2 v bar minus 3 w bar. So from this you will get w bar, whatever it is. Once you get w bar, whatever is the w bar you are getting from this one, and straight away use that one in this u bar dot w bar. U bar dot w bar, you are now going to get this value as equal to this one. So here very clearly one formula we are using, that is cross product of v bar with LHS, cross product of v bar with RHS. So whatever is the lambda doesn't matter, you can separate the w bar. Once you know the w bar, straight away u bar dot w bar, because u bar is already given.